Hello Year 4, welcome to the video for this week. Now you've got sheet 28 and 29 set on your learning group for this week, which is all about measurement units and using decimals to convert between the units of measure. So I thought we'd go over that today because it's quite a tricky subject. So we're going to talk about decimals and we're going to talk about units of measure. So to get us started, we need to make sure we're clear. We know how to convert between the different units of measure. Okay, so I've got written down here on this piece of paper, we've got 1 centimetre is how many millimetres? I want you to have a think about what that might be and see if you can call it out. Now, if you're not 100% sure on these, or if you don't know them really well, I would suggest that you write these down, and this can form part of your homework. You might want to write it down on your sheets, your math sheets, or on a separate piece of paper, but it'll be really useful to have these written down, particularly if you're not 100% sure on what some of them are. Okay, so I would suggest maybe writing them down along with me as we do it. So 1 centimetre is how many millimetres? So remember, with centimetres, that's what we have on our ruler, what we measure in here. And millimetres are the little lines in between, so an even smaller unit of measure, okay, for measuring really tiny things. So how many millimetres are there in 1 centimetre? There are 10. Okay, how many centimetres would be in a metre? So this is 30 centimetres, this ruler. But if we had a whole metre, how many centimetres would there be? 100. And then for a kilometre, how many metres are in a kilometre? How many metres in a kilometre? There are 1,000. Okay, so if we know that there are 1,000 metres in a kilometre, how many grams in a kilogram? We've got kilometre and kilogram here, very similar. How many grams are in a kilogram? Use this answer to help you. It is 1,000 again. How many millilitres in a litre? We've got a jug, a measuring jug. How many millilitres is equal to 1 litre? 1,000 again. How many pennies are in a pound? 100, of course. Now this one at the bottom is an extra one. You don't necessarily need to write this one down. This is just a bonus one that I wanted to teach you. This is a centilitre. Now we don't use these very often, but occasionally in a recipe or on a measuring jug, you might notice that it says CL. Now centilitres are a bit like centimetres. So I wonder if you can work out how many millilitres would be in a centilitre. If there are 10 millimetres in a centimetre, how many millilitres would be in a centilitre? There are 10 as well. And some of the activities that we're going to work through today on this video, that one might be useful for. You don't need it for your workbook pages, but it might be useful just for the video session today. Okay, so we've got these written down. So as I said, I would suggest maybe having these written on a piece of paper for you to use as you're working through the video and your pages for this week. Now, just a quick thing before we move on. Cent, so centimetre, centilitre. Cent, the word cent actually means 100. Okay, which makes sense if you think about it, because if you have a look at this, centimetre, 100 in a metre, and there are 100 centimetres in a metre. So if you see cent, that's kind of giving you a clue that it's got something to do with 100. The word mil or kilo both mean 1,000. So again, if we have a look here, we've got kilometre. There are 1,000 metres in a kilometre, a kilometre, because kilo means 1,000. There are 1,000 grams in a kilogram, 1,000 of the grams. This one's the other way round. It's not a kilolitre or a milliliter this side. We've got 1,000 millilitres in a litre, but mil still means 1,000, so there's 1,000 of them in a litre. So if you ever see mil or kilo, so milliliter, millimetre, kilogram, kilometre, it's relating to 1,000, so your units are going to be in thousands. Centimetre, okay, cent, you're going to be thinking of 100, so there are 100 centimetres in a metre, and there are actually 100 centilitres in a litre. So that's just a little extra for you. Cent is relating to 100 and mil and kilo are related to 1,000. Now let's just use that information to help us work these out here. So if we know that 10 millimetres are in 1 centimetre, okay, then how many millimetres are in 3 centimetres? So to work that out, you take the 3 here and you multiply it by 10, because for every centimetre we have, and we have 3 of them, there are 10 millimetres. So we have 1 centimetre that has 10 millimetres, another centimetre that has 10 millimetres, and another centimetre that has 10 millimetres. So we've got 3 lots of the 10 millimetres. And so what's that answer? 3 times 10 is 30, of course. Okay, so we use the main unit of measure, which is why I said these are really important to have written down. We use those to help us convert when we've got other numbers and it's not just one. So have a look at this one. We've got 1 kilogram is 1,000 grams. So 5 kilograms. So we're going to take our 5, and for every one of those kilograms, there are 1,000 grams. So we're going to do 5 lots of the 1,000 grams. So what's 5 times 1,000? Of course, it's 5,000. Okay, so we use that to work out, use these base conversions that we've got here to help us work out other ones. Now you can use it the other way round as well. If we have a look at these questions, this time we've got the number of millimetres and we need to work out the centimetres, the number of millilitres and we need to work out the litres. So 40 millimetres is how many centimetres? So what you do here is you divide, you have 40 millimetres and you divide by 10 millimetres, because what you're working out is how many of these 10 millimetres will fit into the 40, and then that will tell us how many centimetres there are, because we know that for 1 centimetre there are 10 millimetres. So if we had 10 millimetres, we're looking at this one, and we divided it by the 10 millimetres that are in each centimetre, it just gives us 1, because of course 10 millimetres is just 1 centimetre. But 40 millimetres, if we divide by the 10 millimetres, we're working out how many 10 millimetres will fit into 40, and that will tell us how many centimetres there are, because this is 1 centimetre. So 40 divided by 10, how many 10s are in 40? It is, of course, 4. So it's 4 centimetres. So how many of the 10 millimetres, which is the same as a centimetre, will fit into the total, which is 40 here, and that will tell us how many centimetres there are. So same idea with this one. We've got 6,000, and our base unit of measure, if we look up here, is there are 1,000 millilitres in a litre. Okay, so we're trying to work out how many litres is in 6,000 millilitres. So we're going to divide by 1,000 because we're going to see how many thousands will fit into 6,000, and that will tell us how many litres we've got, because each of these is the same as a litre. So how many thousands will fit into 6,000? The answer to that is 6, which is the same as 6 litres. Okay, so we've worked out that 6 of these thousands will fit into 6,000, which is the same as 6 litres. That's how much it makes. So you use the units of measure to times or divide, to move between them and convert. Now we're just going to have a little look at decimals, and when we're timesing and dividing by 10 and 100, because we're going to be doing quite a bit of that today, and dividing by 1,000 and timesing by 1,000. So I'm just going to show you a website which you can use as well at home to just help you work out a question if you can't figure it out on paper, and it will just explain a little bit more about what decimals are and how they fit in. So this is called moving digits, and I'll put the link to this under the video because you may well want to use this to help you with your tasks this week. So what you can do is you can drag down a number from the top. And so if I pop it there in the ones spot, now down the bottom I can times by 10, I can times by 100, and I can also divide as well. So if I click on times by 10, it will show how the number, when you times by 10, you don't just add a 0 on the end. You notice a 0 has appeared, but it's actually moved up the place value grid. It's got 10 times bigger. And each of the columns in a place value grid are 10 times bigger than the one before it. And so it's just moved up one place to the left. Now, because the 4 has moved up to this column, we now need to fill in the space with a 0. If I times by 10 again, it's going to move another space up. Now, when you're timesing by 10, it only moves one space each time. But if you were timesing by 100, it actually moves 2 spaces all in one go. And to work out why, and to remember how many places you need to move, you can look at the number of zeros there are in the number. So if you times by 10, 10 has 1 0, and that means it's going to move one place up because it's just going to make itself 10 times bigger. Okay. If you're timesing by 100, 100 has 2 zeros, so it's going to move 2 places up. And because there are there's 10 times 10 in 100, so it's two jumps of 10 times bigger. If you had 1,000, you'd move 3 spaces up because there are 3 zeros, so it would be 10 times 10 times 10 times. Now, when we divide, it's the same thing, but if we're dividing by 10, it will move 1 space back down, 1 space back down. And if we're dividing by 100, it will move 2 spaces back down. Now, we can have a look at these decimals as well. If I had 54 and I divided it by 10, it's going to shift downwards. It's going to get 10 times smaller, and it's going to shift down towards the right. So there you go, 5.4 that now is. Now it's got 10 times smaller, which means that if you added 5.4 to 5.4 to 5.4 to 5.4 10 times, you would end up with 54. So you've just made it 10 times smaller. Now, decimals, remember, are anything on the right hand side of this decimal point, so anything that's point anything, is not a whole one. It's smaller than 1, because these are our ones on the left hand side of the decimal point. We've got 5 units here, and then we've got 0.4. So anything that is a decimal is not a whole number, it's a bit of a number. Now, as we know, everything along the place value gets 10 times smaller or 10 times bigger, whichever way it moves along. And so when we have 1, when we divide it, one whole one, into 10 equal bits, okay, we'll end up with a bit of a 1. So if you had 1 cake and you divided it into 10 slices, you would have a 1/10 of the cake. And we can change. If I press the HTU button down here, it changes the labels to show us that we've got our units, but the first space in the decimal chart column is actually the same as 1/10, because of course you've taken a whole one and you've divided it, you've made it 10 times smaller, so you've divided it into 10 pieces. If then you make it 10 times smaller again, that means if you had your cake, you've divided it into 10 pieces, and then you've cut every one of those 10 pieces into 10 other pieces. So you will actually end up with 100 pieces in the end, and the number would get even smaller. So if I just change the labels back again, 0.1 or anything point something, anything in this column is actually the same as tenths. Anything in the next column down in our decimals is actually the same as hundredths, because we've made it 10 times smaller and then 10 times smaller again. Now, if you had your cake and you had a one whole cake, you cut it into 10 slices, you would end up with your tenths. Then if you cut each of those 10 slices into 10 new slices, you would end up with 100 slices altogether, which is where we are here. And then if you took those 100 slices, it would have to be a very big cake to do this, and you cut each of those 100 slices into 10 more pieces, you'd actually end up with 1,000, and you'd have 1,000 pieces. So it's got 10 times smaller, 10 times smaller, 10 times smaller. So we can work out, use this to help us work out when we're dividing by 10 and 100. So if I just reset it a minute and let's choose some new numbers. So if I had, let's make it bigger, 830, okay, if I divided it by 10, so it's going to get smaller, it's going to move down 10 times smaller, what would the answer be? Divide it by 10. It would be 83. Now, if I divided it by 10 again, what would the answer be? It's going to get 10 times smaller again. It's going to move down. It would be 8.3. That's right. Now, if I just go back to where I was, now if I divided that by 100 all in one go, that means it's going to move down 2 spaces in one go. So it's going to jump down and jump down again. Okay, so jump, jump. Right, so sometimes you do more than one jump in one go if you're dividing by 100. If you were dividing by 1,000, it would move 3 spaces down and would move again, and you'd end up with 0.83, which is a number that is not a whole number, because we haven't got any wholes here, we've just got bits of a number. This number, 8.3, is 8 whole ones and then a bit, 8 and a bit. Now, you can use this website to help you with the questions we're going to do today, and we'll come back to this later. But you can also make your own on paper with little cards, and I'm just going to show you how to do that now, because you might prefer to do that because it's a bit more active, a bit more kinesthetic, and it means that you can move things around rather than just letting the computer do it. So I'll show you that now. Okay, so all you need to make your own is just a piece of paper which you can divide up. You can have thousands, hundreds, tens and units, then you have a decimal point, and then you've got the 0.1, so the first decimal place, which is the same as a tenth, and then the second decimal place, 0.01, which is the same as 100th, so one whole one that's been split into 100 smaller pieces. You could have tens of thousands as well if you want to make it bigger that way, but this should be enough just to get the idea. So you also need just to cut up a piece of paper into 10 little squares or rectangles and write on digits 0 to 9. You might want to have more than one of each digit possibly. You might find if you're using this to help you with questions from your book, then you might end up needing 2 of the same number, so you could just have some extras. So just like on the website, you pop in a number that you want to work out. So if I had 1.2 and I wanted to times it by 10. Okay, I wanted to times it by 10. So when you're timesing, you're making it bigger, so it's going to move up towards the bigger numbers. And because it's timesing by 10, 10 has 1 0, so it's going to move up one place, just 10 times bigger. Okay, so your numbers will move up together, one space. So 1.2 times 10 is 12. Now what you need to remember is when you are doing this on your own and not on the computer, is they must stay together. Even though they're in different columns, even though there might be a decimal point between them, they have to move as one. Okay, you'll never have, when you make something 10 times bigger or 100 times bigger, you'll never have just one digit that goes off and then the other one's left behind. They always move together. And then if there are any gaps left before the decimal point here, we fill them with a 0. Okay. These ones don't matter because point nothing is just nothing else. Okay, so if we had 1.2 and we times it by 10 and we got 12. If I times it by 100, that's 2 spaces, 1, 2, and then we fill that space there with a 0, so 120. Now you'll be using this to help you work out some measurement units and converting between units. So for example, if you had, because we were working out earlier, if we had 1 kilogram, how many grams is that? And so 1 kilogram, we know that there are 1,000 grams. Okay, so 1 kilogram was 1,000. But if we have 9 kilograms, to work out how many grams in 9, we took the 9 kilograms that we have and we multiply it by 1,000. So for every whole kilogram that we've got, we also have 1,000 grams. So there's 9 lots of that 1,000. So we can do that on here. So if we do 9 times 1,000, so if you're timesing by 1,000, you're timesing by, you're moving it up 3 spaces because it's getting 10 times bigger, 10 times bigger, 10 times bigger, and 1,000 has got 3 zeros. So we'd go 1, 2, 3. So that is on the thousands now. Now we can't just leave this blank. You would have to fill this in with zeros. So this is why you might want some extra zeros. Okay, or you could write in 0, 0 there, which I'll do now. Okay, so 9,000. So 9 kilograms is 1,000 grams. So we've timesed it by 1,000 because each kilogram has 1,000. We've moved it up and that's given us how many grams are in 9 kilograms. We might come back to this later, but if you want to make one of these at home, I recommend it because it's a good visual way to see what is happening and it allows you to move the numbers around. Right, now I'm just going to show you a program on the computer which is going to teach us a little bit more about converting between units. Okay, so let's have a look at this activity together. So this says this Scout is 157 centimetres tall. How tall is this in metres? Okay, so we know that every 100 centimetres equals 1 metre. So it says there, this is the conversion factor. So when we were writing out at the beginning of the video, all the units of measure and how they convert between, that's your base conversion. So that's the main thing that you're going to be working from. So that's why we needed to go through it at the beginning. So we know 100 centimetres is 1 metre. So we must find out how many lots of 100 centimetres there are in 157 centimetres, because then that will tell us how many metres there are. Okay, because 100 centimetres is a metre, so we need to work out how many 100s go into 157. So we do 157 divided by 100. Now 157 divided by 100 is 1.57. Remember, it would move down the place value chart 2 spaces. If you're not quite sure how it got there, you can use that moving digits or your paper version. You do 157 You divide it by 100, so it moves down 2 places in the place value chart, which gives you 1.57. So that tells us that there is 1 whole metre in 157 centimetres and then some left over. So it's the same as saying 1 metre 57 centimetres. So we've got 1.57 metres. So it's just over 1.5 metres. Now, how tall is this in millimetres? Now, that's a tricky one. So if every 1 centimetre is 10 millimetres, okay, so if we know that every 1 centimetre is 10 millimetres and the Scout is 157. So to work out how many millimetres he measures, we need to take the Scout's height and work out how many lots of 10 millimetres that is. Because for every 1 centimetre, there's 10 millimetres. So we need to do 157 times by each 10 millimetre amount that we have, times it by each centimetre, which is 10 millimetres, which ends up with 1,570 millimetres, which is how tall he is. So there we can see we've done a division and a multiplication. So to find out how many metres, we had to divide by 100. Then the extra problem was actually working out how many millimetres he measures. And because there's more millimetres in a centimetre, we had to multiply it. With the metres, there are less metres than the number of centimetres, so we had to divide it. Now let's have a look at this next section. We're going to look at section 3. It says the distance between Manchester and Nottingham is 82,400 metres. How many kilometres is this? 82,400 metres. So we need to use our conversion factor. Okay, we know that there are 1,000 metres in a kilometre. Kilo means 1,000 of, as we talked about earlier. So for every 1,000 metres, that's a kilometre. So we need to work out how many of those thousands go into 82,400 to tell us how many kilometres go into that amount. So we're going to divide again. We need to find out how many lots of 1,000 metres there are in 82,400 metres. So we're going to take 82,400, we're going to divide it by 1,000 because we're working out how many lots of 1,000 go into there, because every 1,000 metres is a kilometre. So we're working out basically how many kilometres there are within that amount. And you end up with 82.4. Let's have a look at that on the Moving Digits website. So here I've got 82,400. So this, again, you could do on your paper with your little cards. You'll just have to extend your grid so you've got tens of thousands, and you might need some extra zeros. Now we need to divide by 1,000, okay, because we're working out how many kilometres are in this amount of metres. And to work that out, we need to divide by 1,000 because every 1,000 metres is a kilometre. So we're going to work out how many thousands go into this amount of metres. So when you're dividing by 1,000, it's got 3 zeros, 1,000. So you're going to move down 3 places in the place value chart. Now I'm going to actually do 3 lots of dividing by 10 because that's the same thing, because it's 10 times smaller, 10 times smaller, 10 times smaller. Okay, because 10 you move 1 place, 1,000 you move 3 places. So I'm just going to press the 10 3 times because there's no 1,000 divided by 1,000 on here, and then we can watch it move down. So it moves 1 place down, 1 place down. You can see the zeros disappear because when the zeros go on the right hand side of the decimal point, they don't mean anything. If there's no other numbers, they just fall off the bottom. And then we go down again. So 82.4. So that tells us how many kilometres were in that amount of metres. Now, if we were given this number and said 82.4 kilometres, how many metres is that? We would have to multiply 82.4 by 1,000 because every kilometre we've got, which is 82.4, is worth 1,000 metres. So we would have to multiply it by 1,000 to work out how many metres we've got, which takes us back to the beginning, 82,400. Let's have a look at the next section. What is 348 grams in kilometres? Now we're just going to move these kilograms. We're going to move these grams and kilograms into the right bit here. So we're going to draw some of these loop diagrams in a minute, but let's just have a look at this one first. So we've got kilograms and grams, and so the larger unit is the kilograms. Okay, that's the bigger amount. So we've got the small unit is the grams. Okay. Then the next section is what is the conversion factor that links these two measurements? Okay, now that's asking us how many grams are in a kilogram. Okay, how can we transfer between grams and kilograms? And how many was it? Kilo means what? 1,000. So there are 1,000 grams in a kilogram. So that means that when we are converting from the larger unit, okay, to the smaller one, we're going to multiply by whatever our conversion factor is. When we're moving from the smaller unit, we're going to divide to work out how many of the bigger amount that we have. So to go from bigger to smaller, you multiply. So it's kind of the opposite of what you might think. Big to small, you multiply. Small to big, you divide. So if we want to work out 348 grams in kilograms, this is a small unit because we're in grams, 348 grams. To get to kilograms, we need to divide, because what we're going to do is work out how many thousands fit into 348, which will tell us how many whole kilograms we've got, or bits of a kilogram that we've got. So we're going to do 348 divided by 1,000. Let's work that out on back on that website again. So we've got 348 and we're dividing by 1,000 because we're trying to work out how many thousands fit into 348. Now already you might be thinking 1,000 doesn't fit into 348. Well, that's because we haven't actually got a whole kilogram there. So what we're going to end up with is a bit of a kilogram. Okay, so we don't have a whole kilogram, but we'll still end up with an amount of kilograms. It will just be a decimal amount. So let's divide by 1,000. So that's 3 spaces down. I'm again going to do my divide by 10 3 times. See where we end up. 1, 2, 3. So we end up with an answer 0.348. Now we don't say 0.348. I'm not entirely sure the reason behind it, but when it's a decimal, we just say the digits separately, 348. Okay, because it's not 348, because it is only a bit of a number. So we've got 348, 0.348, and that is the amount of kilograms we've got. So if you remember, if you know, 0.5 is actually the same as a half, because that's 5/10, which is the same as a half. So 0.5 is the same as a half. So actually we don't even have half a kilogram there. So we don't have any whole kilograms, but we still do have an amount of kilograms. It's just not a whole amount. So 0.348, that's what we think it is, 0.348. Very good. And that's the answer there. Now we're going to create some of these loop diagrams, and I'd really like you to write these down because I think they'll be really, really useful when you're doing your work. Okay, so these are the loop diagrams that we're going to do, and as I just said, I would really like you to write these down because we're going to do an activity after this, and these will be so useful and so helpful to give you the right answers. And it will also be really useful when you're doing your sheets, your Year 4 sheets that have been set for this week. Now, this video is quite lengthy because I wanted to talk to you about quite a few different things because it's quite a hard topic, learning about converting measures and decimals. So what I suggest is that we complete these loop diagrams together, and then I've got an activity on the screen for you to have a go at, and we'll start it together. And then I suggest maybe you leave it for today afterwards, and then tomorrow you come back and you watch the rest of the video, and then you have a go at completing your sheets. You might want to start your sheets today, but in the later part of this video I will be going through a few of the trickier questions with you, so you might just want to hold fire for a minute. So if we do these loop diagrams, and then I've got an activity which you can try, and if you who've been working really hard up to that point, you might want to have a pause for today, or maybe come back to it later and then watch the rest another time. There's quite a lot to go through, quite a lot to teach, and your brain might explode if you go on for too long. But you never know, if you've eaten your Weetabix, you might be able to carry on all the way through. So the first thing I need you to do, and I would like you to pause while you do this, is to copy out what I've got written down in front of me on my paper here. So we've got 6 loop diagrams: centimetres, millimetres, millimetres, centimetres, meters, centimetres, kilometres, meters, kilograms, grams, litres, millilitres, pounds and pence. And I've put the arrows in and times and divide signs there. Now we're going to put the numbers in together in a minute, but I just want you to get to that point so that we can fill in the numbers together as we go down. So please pause and write this out on a piece of paper. Make sure you get the arrows the right way round and the signs, and also make sure on the left is the biggest unit. So a centimetre is bigger than a millimetre, so make sure it's on this side. A metre is bigger than a centimetre, make sure it's on this side. Alright, so if you just pause and then play the video when you're ready to carry on. Okay, right, I'm just going to move this down so I can write a bit more easily. So just like we had on the screen a minute ago, we had that diagram that was telling us to times and divide. So you work out your base conversion, your conversion rate, and by doing that, that's looking back at thinking about what we did at the beginning of the video. Basically, how many millimetres are there in a centimetre? Okay, how many millimetres are in a centimetre? So there's 10. So we are timesing by 10 and we are dividing by 10. Okay, because if we have an amount of centimetres and we want to find out how many millimetres that is, so if we had 5 centimetres, if we times each 5 centimetres by 10, because there are 10 millimetres in each one, we will find out how many millimetres are in the 5 centimetres. And if we had an amount of millimetres, so 50 millimetres, if we wanted to know how many centimetres that was, we would divide by 10, so work out how many tens fit into the 50, which would tell us how many centimetres we've got. Okay, so this one here, how many centimetres in a metre? 100. So to get from metres to centimetres, we multiply. To get from centimetres to metres, we divide. Make sure you're writing these numbers in along with me, because you're going to need them in a minute. Okay, now the next one, how many metres are there in a kilometre? Remember what kilo means. Yeah, 1,000. How many grams in a kilogram? Also 1,000. We will practice using these loop diagrams in a minute, but let's just get the numbers written down. Okay, let's look at the last two. How many millilitres in a litre? Look back at your sheet if you're not sure. 1,000 again, because mil also means 1,000. And how many pence were in a pound? 100. Okay, so let's just test these just with a couple of examples and then we'll look at some more on the screen. So I've got here £3.50 is how many pence? Okay, so we're going to use the loop diagram for pounds and pence to work this out. Now I've drawn the arrows in here to help us to know what to do. Now we've got the pounds and we need to work out the pence, okay, so we're going to be following the top arrow. So if we have a look up here, we're starting with the pounds. To get to the pence, we're going to multiply by 100 because every pound has 100 pence. So we need to know how many pence are there in £3.5 or £3.50. So what is £3.50 or 3.5? Just because this is written in money doesn't actually make it any different to any other decimals. It's just 3.5. Okay, and it happens to be pounds. 3.5, and we're timesing by 100. Now if you want to use the website to work these out, or use your little digit cards if you made those, you can do that. But if you just want to imagine, if we're timesing by 100, it's going to move up the place value chart 2 times because it's going to get 10 times bigger, 10 times bigger. So what would the answer to that be? 3.5 times 100. 350. Okay, and the decimal point would have ended up at the end there, but we don't need to put it because there's nothing that comes after it, because it moved up the place value chart, and so actually the decimal point has ended up down at the end. Okay, let's just have a look at this one. I've smudged it a little bit there. So how many litres equals 8,780 millilitres? So where's our milliliter one? Oh, it's just here. So we got litres, millilitres. Now we can't start with the litres and go over the top like we did for the last one because we don't know the litres. So we know the millilitres, so we're going to start here and we're going to follow the arrow to go back. So we're going to be dividing by 1,000. The reason we're dividing is because we're trying to work out how many thousands fit into 8,780. Because for every 1,000, that is a litre. So to work out how many litres, we're going to work out how many thousands fit into that amount to tell us how many litres. So 8,780 millilitres divided by 1,000. So again, you need to imagine that number moving along the place value chart. Now, using the website helps, using those numbers helps. You can do this on paper. I'll show you quickly now. So if you had thousands, hundreds, tens, units, then we've got a decimal point, and then it goes to the 0.1 like that. You can do this on paper. If you've got a whiteboard as well, that works really well. So because we're dividing by 1,000, we're moving 3 places along. Okay, so everything all together, remember, it all sticks together, it doesn't separate from each other. So we've got 1.0, we don't really need that 0.0, 2, 8, 7, 8, and then the 0 is now over here. So this, I'm actually running out of room. This is 0.01, this column. So if there's a 0 right on the end, we don't need it, but we need to do one more place. 8, 7, 8. And then the 0 again is right off the end. So we don't need that 0. So we're actually left with 8.78. 8.78, so that was moving it along 3 spaces. The whole number moved along. The 0 we don't actually need to include on the end there because it doesn't mean anything, because it's just right on the end and it's just telling us there's nothing else. We don't need to include it. So it's actually 8.78. So 8, that means 8 litres 0.78 of a litre. So 8 and a bit litres. That's how many litres are in 8,780. Now I'm going to show you a task on the board which you can use to practice a little bit more, and we're going to use these to help us. Okay, so I'll show you the task and then we'll work through a couple on paper, and then it'll be really great if you could work through some more on your own, and then as I said, you might want to leave it there for today, finish the video another day. So this is the activity that I'm suggesting we work through. Now this activity is quite similar to sheet 29, which is part of your set work for this week. So if you would rather just crack on and have a go at some of this sheet, okay, there's quite a lot of questions on there, then feel free. But you might want to just have a go at least at some of these ones, just to get you started. I'm going to go through number 1, number 4 and number 7, just to show you again how to use those loop diagrams. But as I said, you might want to just start and start working through sheet 29, but that's up to you. So I'm going to move back to paper now and go through number 1, number 4 and number 7, and then I will leave you to continue with whichever activity you are going to try. So the first one is 5,000 metres into kilometres. So if we think about metres and kilometres, if I just move along, have a look at our loop for the metres and kilometres. So we are trying to get to the kilometres. We're starting from the metres and we're going to the kilometres. So we're starting from the metres and we're going to move to the kilometres. So we're going to divide by 1,000 because we're working out how many thousands of metres fits into the number that we've got there, because it will tell us how many whole kilometres that is. So we're going to do 5,000 divided by 1,000. That one's not too tricky to work out because we don't have to contend with any other digits. So we've got 5,000 divided by 1,000, okay, because to get from this one to this one, that's what we need to do, divide by 1,000. How many thousands are in 5,000? What's the answer to that one? How many thousands are in 5,000? There are 5. So 5,000 metres is 5 kilometres. Now this one is an interesting one. They've put this in, I think, just to be quite mean. It's saying half a kilometre because it wants you to think of that as a decimal so that you can put it into metres. So what did I say? Which decimal was the same as a half? So obviously a half is smaller than 1, so it's not going to have any kind of units, it's just going to be a decimal number. What is the decimal that's the same as a half? 0.5. So actually we're working out 0.5 kilometres in metres. Okay, now so this is the opposite to the one that we've just done. We're actually starting with the kilometres this time, and we're going to work round to the metres. So we need to times by 1,000 because we need to work out how many lots, timesing by 1,000 because 1 kilometre is 1,000. So we're going to times this number by 1,000 to tell us how many metres are in the half a kilometre. So we're going to do 0.5 times 1,000. Okay, so you need to think about it moving along the place value chart. 0.5 times 1,000. Okay, now if you imagine we've got 0.5, if you imagine this in columns, so that's where our decimals start. Okay, we're timesing by 1,000, so it's going to be moving 3 places along. Now, as I've said before, the numbers that we've got here, so the 0 and the 5, they're not going to become separated. They are always going to be stuck together. But just in order for you to visualise it, you might want to just think about the last number and where this last digit is going to end up. And then we can put in the other ones. So the 5 is currently on the decimal point side in the first decimal place. This is our units, our tens, hundreds, thousands. Okay, so just think about where that 5 is going to end up. So it's in the decimals at the moment. It's going to move 3 spaces up. So it's going to go to the units, the tens and the hundreds. Okay, so the 5 is going to end up in the hundreds. Now the 0, obviously because they're not actually going to become unstuck, would go with it in front. And any spaces we've got here before the decimal point are going to be filled in with zeros. Now we don't need that 0 that's in front, so actually that 0 can disappear. So we're left with 500. So when you're timesing, you can think about where will that last digit end up. You can kind of count along and then make sure you've filled in all the other digits as well to make sure they've stuck together. Let's have a look and see if we can do a similar thing with this one. So 78,521 metres is how many kilometres? So let's look at our conversion loop. So if we're working from metres to kilometres, we're going to follow this arrow, which is dividing by 1,000, because we're trying to work out how many thousands fit into the amount that we've got, which will tell us how many kilometres fit into that amount. So we're going to divide by 1,000. Okay. Now again, you might want to visualise this written out. Okay, we've got much more numbers this time. So let's just draw some columns. So again, you can do this on paper, or you can use the website, or you can use your own cards if you decided to make your own little flashcards on a grid. Now this gets to 1, okay, that's 1 unit, so actually the decimal point would be starting here, but we don't have anything else on the other side. Okay, let's just put some more columns in. So we are dividing by 1,000, okay? I'm putting extra columns in here because this number is going to move down and it needs somewhere to go. So this is the first decimal place, okay, so 0.1, which is the same as a tenth. This is the second decimal place. And this is the third decimal place, 0.01. So it's 10 times smaller again, which is 1,000th. Okay, so we're going to move it down. Now for this one, when we did this one, I said, think about the last digit and think about where that will end up and then work from there. Here, I'm going to suggest think about the first digit and think about how far down it's going to go, and then we can fill in the other digits from there. So the 7 that we've got here, if we're dividing by 1,000, we're going to be moving down 3 columns. So this one's going to go 1, 2, 3. So the 7 is going to end up here, which means the 8 is here, the 5 is here, the 2 is here, and the 1 is here, and that's our decimal point line there. So we've ended up with 78.521. Crazy number, 78.521, which tells us that there's 78 whole kilometres, and then we've got 0.521, which is pretty much a half. Okay, so we've got about 78.5 kilometres. So it's told us the total number, and then we've ended up with a decimal because it hasn't just got zeros on the end, it's not a nice round number, so we are going to end up with some leftover. And actually this means here we've got 78 kilometres, and then we've got 521 metres left over. So that's the answer for those ones, and that might help you with that activity if you're going to do it. I'll pop them into the website now, and then you can decide which activity you're going to try. Right, so I've popped in the answers that we worked out together, and they're right, thankfully. And you now can decide whether you continue working through these, and then if you pause the video, when you're ready, you can play it, and then I'll reveal the answers. or you can have a go at working through some of those questions that you've got on sheet 29. Depends whether you want a little bit of help first or whether you're happy to get going. Okay, so pause now, work through these, and then I'll reveal the answers when you click play. And here are the answers to that little task. So I've written them in, there's a tick next to them to show that they are right. If there are any that you got wrong, have a look and see if you can work out why you got them wrong. And if you can't work it out, send me an email with the one that you were struggling with, or ask an adult and see if they can explain it to you. And just make sure you are using those loop diagrams to help you. And remember, there's the website as well, the Moving Digits website, that you can use to check or go over some of your answers. Now, at this point, as I said, you may want to pause for today and finish off tomorrow. I'm going to crack on now with having a look at another activity online, and then I'm going to go through some of the questions on your worksheets for this week. So if you've eaten your Weetabix today and you want to continue, brilliant. If not, you might want to pause for today and play from this point tomorrow. Right, so we're going to go through this little activity, which won't take very long, but just practices a little bit more about converting between the units. So it says this crab has a mass of 4.32 kilograms. So remember, a mass is how much it weighs. This fish has a mass of 3,487 grams. Whose mass is greater? So it says to compare the masses, it is best for them to be in the same unit. Let's convert 4.32 kilograms into grams. So we're going to change the crab's weight measurement into grams so that we can easily compare it to the fish's. So I'm just going to flip over to another page so we can have a look at this in detail. So we're going to convert 4.32 kilograms into grams. So let's have a look at our loop diagram for this unit. Kilograms into grams. So if we're going from kilograms to grams, we follow the top arrow and it's multiplying by 1,000. So we're going to do 4.32 times 1,000, because for every kilogram we have here, the whole ones and the bits of ones, the decimal ones, there are 1,000 grams. So we're going to multiply all of the kilogram amounts that we've got here by the 1,000 grams, and it will tell us the total number of grams that we have within that. So if we had 1 kilogram times it by 1,000, we'd get 1,000 grams, because there's 1,000 grams in 1 kilogram. So we're going to do 4.32 times 1,000. So that means it's going to move 3 places along the grid. Now I'm going to go onto the Moving Digits website to work this one out. Remember, you can use it too when you're doing your homework. So 4.32, and we're going to times it by 1,000. Now remember, 1,000 has 3 zeros, so it's going to move up 3 places along the place value chart, which is the same as 10 times bigger, 10 times bigger, 10 times bigger, because 10 times 10 times 10 is 1,000. So I'm going to do 3 clicks of 10, and there's going to be one place for each click. So 10, 100 times 1,000, and there we go. 4,320. 4,320. So that is how many grams the crab weighs. 4,320. Let's pop that into the website. $4,320. Well done. So it says whose mass is greater. So the crab is 4,320 kilograms, and the fish is 3,487. So who weighs more? Whose mass is greater? It is, of course, the crab. Well done. Now I'm going to pop on over and just go through some of your pages that you've been set for your homework this week, because some of them are a bit mean and a bit tricky, and I wanted to give you a bit of a helping hand. So you've been set 2 sheets, well 3 sheets this week, but 2 of them to do with units. So there's sheet 29, which is just a lot of questions based on converting between measurements. And you can do these using the loop diagrams, which we've talked about. So I'm not going to go through those ones because we've done quite a bit of that already, and we did that in the last activity. But just use your loop diagrams for this, which is why I asked you to write them down. We're going to have a little look at sheet 28 because there's some bits on here that are a little bit mean, a little bit confusing. So the first section should be fairly self-explanatory. You just have to change the first column into pounds, the next one into centimetres, and the next one into metres. So you're going to be using these 3 loop diagrams to help you. So if you're going from pennies into pounds, you're going to be working on the bottom arrow. So you're going to be dividing all of these by 100. Okay, some of the trickier ones might be the ones where it's just 8p or 41p. So use the moving digits if you need to, or use your own chart if you made your own one with your little digit cards. So you're working on the bottom arrow there. Now for this one, you're going from millimeters to centimeters. So again, you're working on the bottom arrow here. Okay, so in fact, let's delete those ones that we don't need, okay, because you won't need them for this activity. You're just working on the bottom arrow for these because you're working from pence to pounds, millimeters to centimeters. So you're dividing by 10 for these ones to work out how many 10 millimeters fits into these amounts, because 10 millimeters is 1 centimeter. And then for this one, you're changing to meters. So you're starting from the centimeters and you're going round to the meters. So let's get rid of the top arrow because we don't need it for this. And you're going to be dividing by 100 to see how many lots of 100 centimeters fit into the numbers you've got here, because that will tell you how many meters you've got. So that should be not too tricky. It's a little bit like sheet 28, but it's just focused on pence to pounds, millimeters to centimeters, and centimeters to meters. Now the next part of that sheet is this bit at the top, and it's a bit confusing, this, because although it's actually fairly straightforward what it wants you to do, it's not how we would usually be writing something down, and I think it's trying to catch you out. So it's given you 2 number lines. I've just made them a bit bigger underneath. So we've got up to 1 kilogram on the first one, and then up to 1 meter on the second one. Now it's pointed to various points along the line here, and it wants you to write the measurement. Now, as you can see in the box for this first one, it wants you to write the amount of kilograms. Now, if there's only 1 kilogram at the end, that seems a bit weird because it's not going to be anything higher than that because 1 is only here. And the same for the second one, you've got 1 meter at the end. So why are we writing in amounts of meters along the line? And that's because it wants you to write a decimal amount of kilograms and meters. So to work this out, let's just have a look at how many lines we've got, how many intervals. So we start from 0, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it's the same on the bottom one. So we need to try and divide a kilogram into 10 to see if we can work out what each of these lines is worth. Now remember, 1 kilogram is the same as 1,000 grams. Let's just bear that in mind and remember that, 1,000 grams. And 1 meter is the same as 100 centimeters. Let's also remember that. Okay. So we're going to take this kind of 1,000 here, and we're going to be dividing it between these 10 sections that we've got. So we need to work out 1 kilogram divided by 10. 1 kilogram divided by 10. So let's take away the kg and just have 1 for a minute. So 1, that's just a unit. So if we're dividing by 10, it's just going to move one place down to the right towards the decimals. Because it's dividing by 10, 10 has 1 0, so it's going to move one space. Now, I want you to imagine that if we've got 1 as the units, that means that what comes next is the decimal point, okay? And it's actually 1.0 if you think of it with a decimal point, but of course we don't put in the decimal point if there's nothing after it. So if it moved down one space, what would the number become? So 1 divided by 10, what would that become? It would move down and it would become 0.1, which is the same as a tenth, okay, because we've divided by 10. So 0.1 kilograms. Now that's actually the amount that we have on each of these lines, okay? Each jump is a jump of 0.1 kilograms, okay? And then if there's 10 of them, and then we should get to one whole one at the end. So if we're counting up along here, let's count along and just check that that works. So it will be 0, 0.1, then it would be 0.2. What would the next one be? 0.3, that's right. I'm going to start running out of room along here. 0.4, that's right. I'm going to come underneath. 0.5. The next one would be 0.6, 0.7, 0.8 and 0.9, and then one more than that would take us to 1, because one more 0.1 would actually make the place value tick over. We'd have one whole one and then it would just be a 0. We wouldn't need any more on there, so we'd just be left with 1 kilogram. So if you're looking at where the arrows are pointing, you can use this to help you work out. These are going in jumps of 0.1s all the way up, counting up to 1 kilogram. Now the bottom bit here, again, we've got 1 meter. Okay, so before we did 1 kilogram divided by 10. We're now doing 1 meter divided by 10. So again, this one is the same. 1 divided by 10 is 0.1. And each of these lines is 0.1 meters. So again, going along, we are counting in 0.1s. Okay, I'm not going to fill them all in. And hopefully that will help you to work out what measurement the arrow is pointing to there. So what we've done is we've taken the 1 kilogram, we've divided it by 10, because there are 10 sections, 10 intervals, the same as on the meter line. And we've worked out that each line is worth 0.1. So 0.1, and then another one would be 0.2, and another one would be 0.3, and it would go all the way up to 1 kilogram and 1 meter. Okay, so that's that bit. So use this to help you. And if you want to have that on the screen when you answer questions 19 and 20, please do. Now, the last bit we're going to have a look at is the bottom bit on that page, 21 to 38. Now, I must admit, I think this is a very, very mean set of questions and very tricky. I had to have a look at it for quite a long time to make sure that I knew how to explain it to you. So don't worry if you find this bit tricky and you only manage to do a few of them, or you don't manage to get them all right, because actually I was surprised this was on the sheet, because I thought this was really hard. So let's have a go at trying to work out what it means, and then I'm actually going to give you something to help you, which I hope will speed you through it a little bit more quickly. Okay, so it is underlining certain digits within these measurements, these numbers. So on the first one, it says £4.28, and the 8 is underlined there, if you can just about see. And it wants you to write the value of the underlined figure or digit. So it wants, for this one, it wanted to know what the 8 there in the decimal was actually worth. And that's worth 8p. Now the money ones are a little bit easier because we say the money ones differently. With the measurements, like this number 24, we say 13.09. and it's not as easy to work out. It's not just always going to be worth 9 or always going to be worth 4 over here for number 31. So it's not as obvious, but the money ones are easier because we know there's 100 pennies in a pound, and we say this £4.28. So it's 28, 8p. So that one is worth 8p. So the money ones, so like 22, 23, 27, 28, 29, all those ones with the money, you should find a little bit easier because they should be more obvious. Okay, some of them, like this one, is the pounds there that you need to work out. So 52, what is the 5 worth? Now let's have a look at some of these other ones. So I've written down 2 here, number 31 and 32. So it says 0.48, and that's kilograms. Okay, and it wants you to say, what is the 4 worth? Now we don't have any kilograms. Okay, so it's not worth 4 kilograms because the 4 would have to be here if it was going to be 4 kilograms. This is a bit of a kilogram, and the smaller bits that make up a kilogram are, of course, grams. Now it also doesn't mean 4 grams. So we have to work through and work out how this, what this means. So if it's in this decimal place, okay, remember the first decimal place is actually the same as 1/10 because you've had a whole one and you've made it 10 times smaller. And so this decimal place is the same as a 10th. Now, that is a 10th of a kilogram. Okay, and a kilogram, we know, is 1,000 grams. Okay, so we need to work out what a 10th of 1,000 grams is in order to be able to work out how much that digit might be worth. So 1,000 divided by 10. What's 1,000 divided by 10? It is 100. Okay, so in this column, these are worth hundreds of grams. Okay, because if we had a 5 there, that would be 500 grams, which is 0.5, which is the same as a half. So that's right. So if there's a 4 here, and this column is worth hundreds of grams, then the 4 must be worth 400 grams. Okay, because it's a 10th of a kilogram, which we've worked out is 100 grams, and there are 4 of them, so it's 400 grams. This one at the bottom is similar. Again, we're in kilograms, but it's a different digit that's highlighted here, underlined. It's the 2, and it's the second decimal place. So we know that a 10th is the first decimal place. The second decimal place is 100th because it's 10 times smaller again. Remember, we have a whole cake here. We divide it into 10 pieces. So we've now got 10 slices, but it's not a whole cake anymore. It's 10 smaller bits that make up a whole one. And then if we cut those 10 pieces into another 10 each, we'd end up with 100 pieces. And again, it's 100 small pieces that make up the whole. So these are hundredths. So we need to work out a hundredth of a kilogram. So a hundredth of a kilogram, remember we've got 1,000 grams in a kilogram. We divided by 10 to get to 100. But if we divide 1,000 by 100, so it's another space again, another move along the place value chart, what would it be? So it would be 10 times smaller than the answer we had up there. So 1,000 divided by 100 is 10. Okay, so this place here, the second decimal place for the kilograms, is worth 10 grams. And if there is a 2 here, that must mean that it's worth 2 lots of those 10. So it is worth 20 grams. Okay. Now, It does depend on what your unit is as to whether it's hundreds or tens and the places that you've got here. Because for the meters, centimeters and meters, there are only 100 centimeters in a meter, not 1,000. So the first decimal place there is the 100 divided by 10, which is 10. So actually the first decimal place on number 25 here, the 6, that column is worth 10 centimeters, each one of those. So it is different for each unit, which is why it's confusing and why it's really hard. So I'm going to give you something now. I've given you here some digit values, and I would recommend you having this on the screen or writing this down to help you with when you're working through 21 to 38 on your first sheet. So I'm telling you that 0.1 meters, this 1 is worth 10 centimeters. 0.1 kilograms, the 1 is worth 100 grams. 0.1 kilometers, the 1 is worth 100 meters. So you can use that. So for example, if it was 0.2 meters, if 0.1 is worth 10 centimeters, 0.2 will be worth 20 centimeters. If you've got another decimal place, so 0.01, this decimal place is actually worth 10 meters each. 0.01 kilograms, this 1 in the decimal place, the second decimal place, is worth 10 grams. Now, if we went further than that, and we had 3 decimal places, we would have the 1,000 grams divided by 1,000. So this decimal place here, the third decimal place, 0.001 kilograms, that's your 1 gram there, and your 1 meter if it was 0.001 kilometers. Now, I don't think you need that for this bit, but that's just to show you that obviously we've got tenths, hundredths and thousandths. And if you divided 1,000 by 1,000, you'd obviously end up with 1. So use this to help you. And again, if you've got any questions, please do email me, because this is hard. And as I said, I had to sit down and have a really good think about it myself. Okay, so if your teacher didn't get it straight away, I wouldn't be surprised if you don't breeze through it either. Okay, so just take your time, use this to help you, and email me if you've got any questions. I hope that's been helpful this week. It's a bit of a longer video because I wanted to go through quite a few bits with you. Really would recommend making sure you've written down those measurement units at the beginning. So 100 centimeters in a meter, 1,000 grams in a kilogram, because we've come back to that a lot, so you will use it a lot. Also make sure you've written down the loop diagrams, because you're going to be using those a lot as well for the second page. And remember, the link for the Moving Digits website is under the video. Please use that. If it's helpful to use that when you're working out your answers, then just use it. It's not cheating. Use it anyway. And remember that you could also make your own charts with little digit cards that you could physically move yourself, as I showed you earlier in the video. Good luck. And as I said, let me know if you need some more help. Bye.